Good morning, class. I hope you are all doing well. I'm probably at home right now grading your tests and getting caught up, and at the same time trying to get over this little sickness that I picked up the other day. So anyway, hang in there. We are going to do 18-3 today, and it's good. I know I didn't quite finish 18-2. Don't worry. I will pick up the pieces when I get back. There's just a couple little terms like isotopes and whatever that I have to pick up when I get back, but we'll do that on Monday sometime, and we'll just do this 18-3 thing because it's a good section for us to do. All right, a couple things we're going to finish up today, or we're going to kind of learn. Number one, we are going to recognize that the periodic table has developed over time, and it's still changing. I mean, the periodic table you guys use has been around for a few hundred years, but before that, it wasn't like that at all. I mean, there's a history behind that too. So we'll learn about a little bit about the history, not too much. And then we're going to draw these things called energy level diagrams and electron dot diagrams. And after drawing these things, it's going to help you understand why elements bond with each other. And why is that important? Well, if you can understand why things bond with each other, you can start to understand how products like medicines and perfumes and other chemicals are made. You can understand why things are dangerous and what to stay away from. And you can also start to understand the chemical interactions in your own body so you can better take care of yourself. Okay, so today though, it's just a stepping stone. That's not all going to fall into place today. You're not going to understand all those things today, but this is just a stepping stone for us to get there. So here we go. Let's do it. On the periodic table, first of all, let's do the history. This will not take very long at all. It's organized by atomic number. Okay, now it always wasn't organized by atomic number. We actually had three people that I'm going to tell you about. There's John Dalton, Dmitri Mendeleev, and Henry G.J. Moseley. Looking at the periodic tables, they're very different from each other. John Dalton's was pretty simple. He just gave each element a symbol. There was nothing else really to it. I know he did some experiments, but this was what his periodic table looked like. Dmitri Mendeleev, instead of organizing his periodic table by symbol or whatever, he went with atomic mass. Okay, now this is different than our periodic table because our periodic table is by atomic number. He decided to organize it by atomic mass. So it looks very much different, but you'll notice, like if you look very closely at it, the elements, you got boron, carbon, nitrogen, oxygen, fluorine. Some of them are in order, okay, like our periodic table, but some of them are not if you start to get down towards the bottom. All right, so his is just a little bit different. And then Henry Moseley comes along and he organizes it by atomic number, and that's where we get our periodic table of today. So to kind of tell you this periodic table and sort of explain how this all sort of comes together, the periodic table is organized into these things called groups and periods, okay? So if here's our periodic table, okay. Oh, that's not quite right. Woo! Yeah, okay, something like that. Okay, groups are the vertical columns. So whenever you guys see a vertical column, that's a group. And then as you go across, those are your periods. So, hey, two vocab words for this chapter. Make sure you know groups are vertical and periods are horizontal. Okay? And this is the first step in understanding how to draw an energy level diagram, because the group and the period each tells you something about the element. Okay? All right. So starting off, every element, no matter what it is, has electrons in energy levels. Okay? And the way that you find out how many levels it has is by the period. Okay? So if you look at the horizontal rows, you'll notice like hydrogen at the top. Go ahead and look at hydrogen. That would be in period 1. Hydrogen and helium are the only elements in period 1. If you go down one level, now we're into lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. That would be period 2. Okay? So the period tells you there are 2 levels of electrons in those elements. In the first period, there's only 1 level of electrons, and we represent those by having circles, or we represent those levels as circles when we draw the diagram. So if I was drawing hydrogen, okay, it's only going to have 1 circle around it. But if I'm drawing lithium, it's going to have 2 circles around it. okay? And then eventually we're going to toss electrons in here too, and they're just going to be little dots, okay? So each level has a maximum number of electrons that it can actually hold. So level 1 is kind of wimpy. It's on the inside. It can only handle 2 electrons max. So no matter what, I can't draw more than 2 electrons in that level. If I do, I'm going to get it wrong, okay? There's only 2 electrons maximum. Level 2 can hold up to a maximum of 8 electrons. Level 3 can hold up to a maximum of 18 electrons. And then level 4 can hold up to a maximum of 32. And if you notice on a periodic table, I want you to just check it out and look how many periods are there total. You might have said 7. You might have said 9, okay? But what you need to understand is those bottom 2 periods actually are not separate rows on their own. They actually get inserted next to, if you look at lanthanum, which is number 57, and actinium, that's number 89. Those 2 rows actually get shoved right in there. So they're actually, those bottom 2 rows are actually also periods 6 and 7. Okay? I know that's weird, but those 2 rows get shoved in there. If we actually drew the periodic table the way it should be, it wouldn't look normal. It would look kind of weird and much, much longer. So anyway, just so you know, there's only 7 periods. So the maximum number of circles you could have around one of these things is 7 circles. Okay? Moving on. So after we draw this circle around, all right, I'm going to give you guys some rules here, all right? The first thing you do in drawing one of these diagrams is you determine how many energy levels there are in the atom. And that's all you have to do is look at the period. Then you find out how many electrons are in the atom. And that's what we've been practicing in the worksheets previous to today. So if it's a neutral atom, okay, think how are you going to find out the number of electrons? Okay, you're just going to basically look at the protons, just the atomic number. Since it's neutral, the electrons are going to be the same. All right. So, say for example, boron has 5 protons. Its atomic number is 5, so it's going to have 5 electrons. So in this sort of exercise with energy level diagrams, I'm going to have to place 5 electrons in those levels. Okay. And then the way that I place them is starting at the first level. I'm going to fill each level until I run out of electrons. So for the first level, I can only put in 2. So once I put in 2, I have to move on to the next level. And that's all you do. Once you run out of electrons, you're done. You know, you don't have to fill a level, but if you do, that's okay. So let's do a couple of these together. Hydrogen is probably the piece of cake one, so we're going to go ahead and do it. The first thing you do is write your symbol. So hydrogen is H. And we need to look at what period it's in. Step 2 says, find out how many circles I'm supposed to put around it. Maybe that's step 1, I don't know. It's in period 1, so it has 1 circle around it. And then I've got to find out how many electrons it has. It's a neutral version of it, so I'm just going to put 1 electron on it. All I have to do is put a dot, just like that. All right, you want to make sure these circles are nice and neat and that your dots are really nice and neat. Okay, if we go up one more, let's go helium. Helium is also in period 1. So first you write the symbol, it's He. I look in its period is 1, so it's only going to have 1 circle. But now it has 2 electrons. Usually when you write electrons in, you want to write them as sort of away from each other in these circles because they kind of repel each other. So we're just going to do that. Okay? And that's helium. Boron now, we step down 1 level, so write the symbol, just B. And with boron, it's got 2 energy levels, so do 2 circles. And then the number of electrons is actually going to be 5 because its atomic number is 5. Okay? So there's only 2 in the first level. I've got 5 to play with. But now that the first level is full, I have to move to the next level. So now I'm going to put 3 in the next level, but I'm going to spread them out evenly as I can, just like that. Okay? Cool. So the only curveball to this, guys, that you'll have to kind of play with is if it's an ion. Okay? And if it's an ion, you just have to pay attention to the electrons, okay? Because in ions, the only difference is the number of electrons. So let's say, for example, boron was not neutral, okay? Instead, boron is boron minus 1, okay? Well, if we remember from yesterday, boron minus 1 means that it has one more electron than protons. I know boron has how many protons? Look at your periodic table. Boron has 5 protons, okay? So if it was neutral, it'd have 5, but since it's an ion, it's got one more electron, so it's actually going to have 6. So what I need to do to this diagram is I actually need to add one more electron. And I'm not going to shift them around or anything, but anyway, you just got to add one more electron. If it was minus 2, it'd have one more electron than that. But you just kind of have to pay attention to the charge. That's really important to finding out the number of electrons. Okay? That's pretty much energy level diagrams in a nutshell. So let's move on. The next kind of thing, this right here, I really don't know what this is, guys. Sorry. I think that was an inside joke from a couple years ago. So we'll just, I'm sure you would want a muffin, especially Mason. Mason really probably likes muffins or something like that. But other than that, yeah, I don't know, whatever. So the next thing we're going to learn is these things called Lewis structures. You might hear about that in high school as them called Lewis structures. Or I'm going to call them electron dot diagrams. Okay? And electron dot diagrams are actually even easier than the ones we just did, okay? Because we're not going to draw all the electrons, we're just going to draw the ones on the most outer level. So the first thing you need to do in drawing these electron dot diagrams is you have to find out how many outer level electrons there are in the atom, okay? And there's a shortcut for doing that, and you just have to look at the periodic table and kind of label it. So on your periodic table, I need you to label some things. Just put some numbers down, okay? The numbers are going to go like this. For the first group, this is group 1, you're going to put the number 1. For group 2, you're going to put group number 2. And then you're going to skip all these, okay? These elements right there are those are the transition metals, okay? And then you jump to boron, that's going to be 3, 4, 5, 6, 7, and 8. And the cool thing, guys, is that without drawing those circles in the energy level diagrams, we can find out how many electrons are in the outer level just by these numbers. So here's the deal. Everything in group 1 has one outer level electron. Everything, no matter what. Everything in group 2 has 2 outer level electrons. Everything in this group over here has 3, and so on and so forth. Okay? The only exception to this is helium. Okay? Helium's special because it doesn't have 8 electrons, it has just 2. Okay, so there's only 2 in helium's outer level, but the rest of these down here, those all have 8. So you can rest on that. Okay? Alright, so let's do a little quiz here. How many outer level electrons does sulfur have? So count over. Answer would be 6. How many outer level electrons does hydrogen have without looking? Uno. Alright, just 1 because it's in group 1. Okay, so what do we got to do? To do these diagrams, first find the outer level electrons. Okay? And then after you find out the outer level electrons, you draw the element symbol. And then you draw dots around the symbol. Now there's a specific way you're supposed to draw the dots. Okay? 1 dot per side. Alright? Until all sides have 1, and then you can start to double up, okay? Because electrons kind of have this thing, they want to be away from each other, so you don't want to double them up until you have to. And then maximum in this are 8 dots, because no matter what atom it is, how big it is, the outer level will never, ever, ever have more than 8 electrons in it, okay? It may be able to have a maximum, like the third level can have 18 electrons maximum, but if it's the outer level, it's not going to have 18 ever. It's always only going to have a maximum of 8. Okay, so we never ever draw more than 8 dots in these diagrams. I think every year I have a student who doesn't quite hear this, and they draw like, there's like some elements, like for example, let's go with like silver. Maybe I put silver, let's go with tin. I'll put tin on the homework, and a student will literally write 50 dots around tin. And I'm like, oh, I feel so sorry for you that you missed that 30 seconds of the lecture. But you don't have to ever write more than 8 dots, okay? Think of the dots when you draw them as like drawing around a square. So this is one side of the square, this is the other side of the square, this is one side of the square, and this is the other side. All right, that's where the dots go. So let's do it. Okay, so let's go nitrogen first. We go nitrogen. If we find out how many outer level electrons there are, it's 1, 2, I'm counting over, 3, 4, 5. I see what column, or what group, I should say, nitrogen is, and I've got 5 to place. So according to my rules, I'm going to start on the top and put 1. I'm going to put 1 on each side until I have to double up, and then I'm going to go ahead and double up. Boom! That's it. That's nitrogen. Piece of cake. All right, oxygen. Sorry if I'm going a little fast. Oxygen, 1, 2, 3, 4, 5, 6. All right, I just counted how many outer level electrons it has. It's got 6. I'm looking at my shortcuts. So I'm going to go 1, 2, 3, 4, 5, 6. And that's oxygen. Okay? Now, if you guys are sharp, you're going to start to realize that every element in oxygen's group is going to look the same. Okay? So, for example, sulfur. How many outer level electrons does sulfur have? Yeah, 6. Okay? So, its dot diagram is going to look exactly the same. 1, 2, 3, 4, 5, 6. Okay? So, just so you know, I mean, every one of those is going to be the same if it's in the same group. Okay? All right, let's do fluorine. Fluorine. Whew, voice is going down. 1, 2, 3, 4, 5, 6, 7. Okay, so, that's my wife calling, sorry. Okay, there's 7 electrons in the outer level of fluorine, so we're going to go 1, 2, 3, making sure we don't double up until we have to, and then go 5, 6, and 7. And that's that. And then last but not least, let's do one of the noble gases. We got neon. Neon is one of those that has 8 in the outside, so we're just going to go 1, 2, 3, 4, 5, 6, 7, and 8. And that's it. Okay? So essentially that's how you do those. Again, pay attention for ions, okay? Ions are going to throw you off a little bit. Like, for example, if you had nitrogen, let's go a different color with the pen here. All right, let's say nitrogen was -2. Okay, well, -2 means that it's got 2 more electrons. So what I've got to do is add 2 more dots. All right, that actually fills up the outer, fills up those levels there. Actually, I probably shouldn't have put the dot right here. I should have put the dot right here. Okay, that's good. And then let's say oxygen was actually +1. Okay, if it's +1, it means that I've actually got to take an electron away. So I should probably take off one of these pairs. I don't want to take off one of the single ones because they're happy. But the ones that are paired up, those are the ones that you want to take away because electrons don't really like each other. Okay? I guess I can't really... Ooh, sorry guys, I can't knock it out. Anyway, you would erase one of those electrons on oxygen and you'd be good to go. So just pay attention to ions. Make sure you're counting your electrons correctly and you should be good to go. Alright? Alright, I think we're good. I'm not going to go any further into this lecture. I'll do this all this stuff on Monday. But you guys, I think you're all set to go for the homework. I've got some energy level diagrams on it. There's like 6 of them or 7 of them. Should fly through those pretty quickly. And then I've also got some electron dot diagrams as well. So do those 2 things as we learn why things bond with each other. And good luck. All right, I'll see you guys on Monday.